We're going to take a look at equations that have quadratic form. Now, we've seen how to solve actual quadratic equations in the past. Quadratic form is something that kind of looks like a quadratic, bx dm plus c. Notice here's our quadratic. We have ax squared plus bx plus c. This was our quadratic form from before. This has quadratic form. Notice how similar they are. The only difference, and don't let these ends up here confuse you, all it means is whatever the highest power is, it's twice as big as the lowest power. Now notice the same thing for a quadratic, right? The 2 is twice as big as the 1. The good news is if something has quadratic form, we can basically solve it as a quadratic. We're just going to do a quick substitution to make it look like what we're used to. So let's just go with our directions would be solve, and we'll get our kind of steps here in a second. Let's say I had x to the 4th minus x squared minus 20. All right, so by looking at this, and you were, solve, sorry, equals 0. You'd say, okay, this is a polynomial equation because all of our exponents are whole numbers. You move everything to one side, try to factor, and you say, well, you know what, I don't know how to factor that because it doesn't have one of the forms to do like the AC method on. You say, well, it has quadratic form, right? It has 3 pieces, just like a quadratic. 2 of the pieces have the variable with it, 1 doesn't, and the highest power is twice as big as the lowest power. Highest power is twice as big as the lowest power. That means that it has quadratic form, and this substitution will work. Now, technically, you don't need to do this, but it does make the problem look a lot easier. Here's what we're going to do. We're going to say let u, or whatever letter you want, equal the variable raised to the highest power. If that's true, that means u squared will be the, lowest power, will be the variable raised to the highest power. Okay, now what do I mean by this? Well, in this equation here, we can see that our variable is the letter x. So our substitution here, this is for this problem, we would say let's let u be equal to x squared, right? The variable raised to the lowest power. Now notice, and you can kind of see how this is going to work out. If you square both sides of this equation, you get u squared is equal x to the 4th. So that one just kind of comes naturally from the first one. If you square both sides, you should get u squared equals the variable to the highest power. Now we're going to do a substitution. I'm just going to replace all x stuff with u stuff. So let's see, x to the 4th was u squared minus u minus 20 is equal to 0. So by doing the substitution, I'm just changing how the problem looks. Now it looks like a quadratic, and I can follow all my steps for solving. In this case, this one will factor. This will factor to what? U minus 5, u plus 4 is equal to 0. Set each factor equal to 0 and solve. So we get u is equal to 5, u is equal to negative 4. Now, once you have finished solving for u, remember, u is not what we started with. You need to, once you solve for u, back substitute. Okay, so I'm going to put back what u equal. From originally we said u was equal to x squared. So here we get x squared is equal to 5 and x squared is equal to negative 4. Now, good news, bad news is we basically starting almost all over. Now we have 2 brand new equations to solve. We need to reclassify them and see how to solve them. Well, for each one of these are quadratics, and we can just extract the root. So I'm going to take the square root of both sides. So here I get plus or minus 5. Over here I get plus or minus the square root of negative 4. As soon as you put radicals into the problem, you want to simplify them. For the first one, we can't simplify this at all, so those are those answers. However, this radical we can simplify. That would be 2i. And there we go. There are our answers to this problem. Now, since this original was a polynomial equation, we know we should always have the same number of solutions as the highest power. Now remember, that only works for polynomials. Here our highest power is 4. Notice we ended up with 1, 2, the positive and negative, 3, 4 solutions. All right, so anytime we see something has quadratic form, we're going to do this substitution. Let u equal the variable raised to the lowest power. U squared is going to end up being the variable raised to the highest power. Substitute it in, it's a quadratic, solve the quadratic exactly like you normally would, back substitute, and then you still have something left to solve. All right, so I don't think I have enough room going that way. Let's try another one that maybe looks even scarier than this. Let's see here. Let's say I have 3x to the 2/3 power. Let's do minus 11x to the 1/3 plus 6 is equal to 0. All right, by looking at this, and we were told to solve, you say, oh my God, I don't know what to do. Well, first off, we have to classify what type of equation it is. Now remember, a fractional exponent means that it is a radical problem. So technically this is a radical problem. But you may notice it has quadratic form, right? We have 3 pieces, 2 of them have the variable, 1 of them doesn't, and the highest power is twice as big as the lowest power, right? 2/3 is twice as big as 1/3. So since it has quadratic form, this should work. Let's do a substitution. We let u equal the variable's x, raised to the lowest power. Then if you square both sides, you get u squared equals the variable to the highest power, right? And you can kind of see that happening. Here we had u is x to the 1/3. If you square both sides, x to the 1/3 squared, of course this side's easy, that's u squared. Power raised to a power you multiply, so 2 times 1/3 is 2/3. So you see how that kind of works out. All right, so let's go ahead and do our substitution. So here we got 3u squared minus 11u plus 6 is equal to 0. All right, this is a quadratic equation. Now, so we can follow our steps for solving quadratics. Step 1, try to extract the root. We can't do that because of this u here in the middle. Step 2, try to factor. Now to factor this, we'd have to do the complete AC method, and I'll go ahead and run through it on this one. If you can't remember how to factor it, go back and review the factoring videos. So to do the AC method, I'm going to do 3 times 6, which gives me 18. I'm going to write out all the ways to get 18, 1 and 18, 2 and 9, 3 and 6. Now remember, when I pick a pair out of here, I need to multiply to get 18, but I need them to add together to give me this middle term here, the negative 11. All right, let's see, the 2 and the 9 will work. That'll multiply to 18 and add up to be 11, but since I need to be negative, they both have to be negatives. Okay, so we rewrite our middle term here using those 2 numbers. So that's going to be minus 2u minus 9u plus 6 is equal to 0. Then we factor by grouping. Out of the first pair, we can take out a u, and I'm left with 3u minus 2. Out of the second pair, I'm going to take out a negative 3, which gives me 3u minus 2. Now we have 2 pieces here, this first term minus this second term. Both of these have a 3u minus 2. If I factor that out, from the first term I have left a u, minus from the second term I'm left with a 3. All right, let's go ahead and move this up over here. So I'm just gonna go, we have 3u minus 2 is equal to 0, and u minus 3 is equal to 0. Solving each one of these, do it in a couple steps. It's 2 divided by 3, so we get u is equal to 2/3. This one's a little bit easier. We just get u is equal to 3. Okay, so there's most of the hard work. We solved for u, but remember, we don't care what u is. We were trying to figure out what x is equal to, so we need to back substitute. We know u is equal to x to the 1/3. So we have x to the 1/3 is equal to 2/3, and I'm just going to bring this down over here. We get x to the 1/3 is equal to 3. All right, we have 2 equations to solve, and technically these are radical equations. You don't need to write this, but you can think about this as, this would be the cubed root of x is equal to 2/3, and the cubed root of x is equal to 3. So you can kind of see how to do this. To get rid of the cubed root, you would cube both sides, or as we saw in a previous lecture, all you got to do is raise both sides to the reciprocal power. So ignore the red step here if you don't need it. I'm just showing you another way that we could represent that. So I'm going to raise both sides to the reciprocal of the exponent. So here I get x to the 1/3 cubed equals 3 cubed. So in the power raised to power we multiply. So that's going to give us 1/3 of 3 is 1. That's why we multiply by the reciprocal so we can make that exponent 1. 2/3 to the 3rd power would be 8/27. Again, power raised to a power here we multiply. That's just going to give me x, and x cubed is 27. All right, now something small and really technical you got to kind of watch out for. Remember when we first classified this, we classified it as a radical problem because these fractional exponents, as we saw right here, are really radicals. Remember, if it's an even root radical, we have to check these answers. In this case, these radicals are cubed roots or odd roots, so we do not have to check these. But if these denominators had been even, we would have to check these answers. All right, let's try one more example here, maybe not quite as intimidating looking. Let's see, let's give ourselves some room here. Let's do something like x plus 3 squared plus 8x plus 3 plus 15 is equal to 0. All right, first off, since we're told to solve, the very first thing we want to do is classify this. This is a polynomial equation because all the exponents are whole numbers. And technically, Eric, technically this would be a quadratic, right? Because if you distributed everything out, the highest power would be 2. So technically one way to solve this would be to distribute everything out, combine all your like terms, and then solve it like a regular quadratic. However, this still somewhat has quadratic form, because notice, it still looks like our quadratic here. So we'll have 3 terms. 2 of them have a variable with them, 1 of them doesn't. But instead of just a single letter, just an x, we have this weird x plus 3. So this is another occasion when a substitution works very nicely. Watch, if we let u be equal to that x plus 3, then of course u squared would be x plus 3 squared, right? Just square both sides. Now by doing a quick substitution, we get u squared plus 8u plus 15 is equal to 0. Notice that now it just looks much nicer and much easier to solve. So from here, this is a quadratic, we can't extract a root. Oddly enough, this will factor. This factors u plus 3, u plus 5. 2 things multiplied together and equaling 0. One of those needs to be a 0. So either u plus 3 is equal to 0 or u plus 5 is equal to 0. Solving each one of these linear equations, hopefully that's easy by now. Just move each number over. So u is -3 and u would be -5. But again, we don't care what u was. We need to figure out what x is equal to. So for the first one, I'm going to replace u with what we said u was. So we get x plus 3 is equal to, what's that, -3. And for this one, I get x plus 3 is equal to -5. Again, like always with these quadratic form problems, once you back substitute, you have 2 brand new problems to solve. Each one of these end up just being a linear equation, so easy enough to solve. Subtract 3 from both sides, so we get -6. Subtract 3 from both sides, and we get -8. Okay, so there we go. There are 2 solutions for this one. Now notice in this case, since this was a polynomial equation, and the highest power was 2, we knew that we should expect 2 answers, and that's what we ended up with. All right. Noticing that something has quadratic form, it's not the easiest thing in the world, but once you notice it has quadratic form, you make the substitution that we said before, use the variable to the lowest power, u squared is the variable raised to the highest power. Do your substitution, it ends up being a quadratic, which we know how to solve by now. Solve the quadratic, back substitute, and then solve the 2 brand new equations that you end up with.